All right, welcome back, statisticians. How are we doing? We are going to start Chapter 7, and Chapter 7 talks about confidence intervals. So what we're going to talk about today is trying to figure out what the population parameter might be for us. We're going to start with an example of an urgent care. Let's say that we have a large urgent care that has a few doctors working there, and we see an average of, let's say, 16 patients per hour, okay? So this is an average for us. So for an average, we're going to use X bar, and we know that this is 16 patients per hour. Now, if I want to estimate the parameter and I want to know what is the average amount of patients per hour for a lot of hours, what is going to be my mu, right? If I want to take this data and from this, I want to estimate what is going to be the actual mean of the amount of patients per hour. It might differ a lot. It might differ a little bit. So, but I do think that it should be in this vicinity, because I have here some kind of an estimator, and this estimator probably a good estimator for the mean. And how do we know it's a good estimator? Well, if I were to look at the distribution of X bar, and we talked about that in previous videos, if I look at the distribution of X bar, I know that it is going to be the bigger the sample that I take, the more it's going to be normal, especially if it comes from a normal distribution. But if it didn't come from normal distribution, if you start looking at sample sizes more than 30, you know that it will, by the central limit theorem, be a normal distribution. So I would like to estimate my parameter, and I'm going to use my statistic over here, something that I got from a sample. Let's get some more information about our sample and see how we can do that, okay? So this is my mean. I also know a little bit about this population. It seems that in this population, the standard deviation is roughly 3 patients per hour, plus minus 3 patients per hour. And this sample over here, okay, this sample over here was taken from, let's say that we had 36 of these hours that we took. And based on this data, we are going to be able to estimate some kind of an interval for our mu, okay? And since I do not know my mu, I'm just going to put it somewhere here. Now, just going to make sure that we are here not losing. So I have this some kind of unknown mu, right? And my X bar, my here, this statistic, this point estimate is somewhere here. Well, I don't know, maybe it's to the left, maybe it's to the right. It could be here, it could be here. It could be right on my mean, but what are the chances of that happening? I don't know. So my point estimate could be in all these different places, and let's put a couple over here. So these point estimates for each one of sample size of 36, I'm going to end up with a different point estimate. And there is going to be variability because every sample is going to be different. Now, what we're going to do around our mean, in order to try to capture it, we're going to build a buffer zone. We're going to build a confidence interval. But that's what it means. We're going to extend these arms, and these arms are going to be these, they're going to be extending in both directions evenly. And we're going to talk about what happens there. So I'm going to be building these intervals. I'm going to be building these intervals around my point estimate. All right. And these intervals, sometimes they will capture my mean. Sometimes they're going to be exactly on the mean, okay? And sometimes they're not going to be enough to reach the mean, okay? Sometimes they will fail to capture the mean. So the point estimate is only when we're going to be building these confidence interval, we are not 100% sure. We are going to say a confidence level, how much we are sure about it, okay? And we'll continue talking about our confidence intervals and what each bit in this sketch means in our next video. See you then.